Well, hello everybody, and welcome to Ellensburg, Washington, USA, home of Central Washington University. On an absolutely glorious day, we're going to be up to 80 degrees Fahrenheit, no wind, field trip. Life could not be much better here, with faith. And Sky Cooley in the building, and Jess and Scene. I see Indigo, I see James, I see Gavin, Romper Room reference for everyone over 75. Great, are we here? We are 5 by 5, wonderful. Let's get you inside of the building, talk to a few of you, and the students will be filtering in, but we have the early birds who are doing their normal thing in here, which is much appreciated. Much appreciated. Yeah, that's the scene cam, everybody. Hi, everyone. Thank you for joining us today. It's 11:50 a.m. I'm going to lower the blinds right now so that this AV equipment doesn't overheat, but our lecture will begin in 10 minutes. So if you're watching this live, you're going to have to wait 10 minutes. If you're watching this in replay, you can skip ahead 10 minutes. That's how that works. If you don't want to see this preliminary stuff. This is the second lecture of the week. We have midterms happening here for the students. There's a lot going on. There are some frayed nerves and so on. So we are going to escape this afternoon to a beautiful place, a very interesting place. Wish you could all come along. Very quiet in here at the moment, unnervingly quiet. Not sure what that's about. Please, guys, talk to each other. You're studying dutifully. Where are you viewing from today? Can I say hi to a number of you before I start visiting with the folks coming in? North Scotty Nerd, you're here almost every time. Great to see you. Happy May Day. Oh yeah, it is May 1st, isn't it? Happy May Day to you too. Cincinnati, Ohio. Thorpe, Wisconsin. Kingsgate, Washington. It's 4 a.m. someplace. Stefano's in Italy. Lauren is in the Netherlands, Orangevale, California, LaPorte, Minnesota, Fairwood, Washington, Yamhill, Oregon, Falls City, Washington. Hey, Kevin? It's gorgeous in Yakima, Washington. Joe is over there in Hogue Hall on campus, just a few buildings away. Hello, Joe. Glasgow, Scotland. Hi, Paul. Kirk from Philomath. Savona, North Carolina. Hi, Chris. Winter Gardens, California. Sunny Centralia, Washington. Methow, Dave. Oh, Dave wants to start a new thing. Instead of all the Garys, we got a bunch of Daves. Chris, you got something you want to say?
No, I'm just excited to go where we're at. We were just talking about it this morning in Lisa's class involving glacial floods and stuff. So
okay. All right. Very good. Chris is exciting everybody to go out to the field side. He was just talking about Ice Age floods and geomorphology, and we're not going to talk a lick about Ice Age floods, but we'll appreciate that area from a whole different point of view. We probably will toss in some floods. It's pretty sweet.
What's the perspective of where everything sits now?
Exactly, man. Exactly. Hamlin, Germany, Northern California, Royal City, Washington, Moscow, Idaho, San Antonio, Texas, Dallas, Texas, Kalamazoo, Gary, Doubting, Arizona. Gerard is in the Netherlands. Milwaukee, Oregon. South End, UK. Chelmsford, England. It's still 70 degrees at 8 p.m. And so on. Thank you all very much. We've got... let me give you a close-up shot of the board. That'll work. Hi, Sabrina. This is Sky Cooley. This is Sabrina.
TV last week.
Yeah.
That's right. Yep. She made her debut here.
Yeah.
Cool. Sounds like you're doing good work.
Yeah. I think so. I'm kind of biased, but.
That's your job.
Jack.
How you doing?
Good. You?
Good.
All right.
I'm just a little hungry though.
Okay. All right.
It's most of it. Ever since, not this quarter, but.
Hey.
So should we write the bullet points in reverse order like last time?
One never knows these things, Gavin. Maybe write them out, get some scissors, cut out the slips, and you can.
Exactly. So just put in a number.
Yeah, out of the blue, it's like, yo.
Put it over Y instead of 3. Put it over Y instead of X.
Yeah, Sky Cooley really wanted to see this quarry that we're going to today, so he drove over from Montana after work yesterday, and he's hanging out at the house for a couple days with Bijou the cat, and I think I'm going to try to film a little bit this afternoon. I don't know. I think I'll see how many are with us and how excited everybody is, but it's a unique place, and even though it's private land, I think I want to do it. So I'll maybe get Sky on camera and have him help us appreciate some of the sediments that are up there that are going to confuse me for sure. So it's Thursday, and we're going to be hustling to get out of here, so there won't be any students visiting with you today after class, but I'm pleased with that as well. I like how the students are happy to do that, and it's pretty weird. You're just looking into a black dot up there, but another skill we're trying to learn here. Very good. How about a few more? No, I got to start thinking. Okay, I'm glad you're with us. You know by now, many of you have been watching these 351 sessions, and it's so wonderful to have you in the classroom with us, but you know, don't you, that I'm focusing on these guys. I'm not really tailoring what I'm doing to you. So occasionally there's some handouts I'm talking about, and that's not available to you. Oh well. The science papers I'm talking about are at a website called nickzentner.com. You click on 351 in the upper right hand corner, you'll see all these science papers, either that these guys are responsible for or the papers that I've read to get ready for these lectures. So when I refer to a science paper, they're all available to you at nickzentner.com. That's nickzentner.com. Enter the promo code Sky Cooley. Thanks for joining us. All right, weird energy this morning. Weird. How you doing, Austin? Front row, Austin. There's Luke. Hello. All good? Okay.
Thank you.
Wiped it on my arm. It stayed in my arm, and I got it an hour later.
Matthew?
It was a lot shorter than I was thinking. For a 2-hour class.
You can thank my class for that.
Skylar? Good.
Well, that should definitely kind of grease the wheels.
But she did say that she's leaning towards.
We were at Wing Central last night.
There you go. Good afternoon, everybody. We are beginning today. It is high noon. We have some empty chairs. Makes sense. It's midterms. It's a high-stress week. The weather is delightful, but we are here. We are locking in. A couple of quick announcements about our field trip, and then I want to go right to my bold opening comments. Sabrina, grad student, in charge of the vans. The 2 vans are parked. They're ready to go. Sabrina and another driver, possibly Ryan, can't know for sure. The vans will be leaving. The vans will be leaving at 1:15. 1:15, departing. And we are going to a very, very special place, so special that Sky Cooley is with us here, sitting on the side. He's come over from Montana to see this quarry that is very, very famous. And so if you're joining us, we're leaving at 1:15. We're rendezvousing at 2:15 at the base of Saddle Mountains, so we're not going right to the quarry. This is all in the email. I'll get your bearings. I'll point out the Cougar Point Tuff high on the cliff as we look south, and then we will caravan as a group. Matthew's driving his own rig because he wants to go tear the place up afterwards, looking for petrified wood. So we'll have our group of vehicles heading as a caravan through an apple orchard and get to this private spot. So it's tricky. So just letting you know that we're going to be well behaved, organized as a group of vehicles, and it's going to be hot. It's going to be very hot. It's going to be a hot climb up this Jeep trail. Have plenty of water. You will no doubt be impressed. Indigo thinks there's just like basalt up there, maybe a little bit of ash. It's way more than that, Indigo. Way more. Way more. And that's what we're doing today in class. We're really trying to make sure that you get the most out of your experience this afternoon with the context I'm providing to you. So possibly I'm doing most of the talking today. I'm not sure. I like our dialogue back and forth, but possibly this is more of a quote-unquote lecture because I want to make sure we have some things straight before we see some of this stuff for real in the flesh. Okay, the Pomona basalt is new to us. More on the Cougar Point Tuff today. That's the title of our gathering. The Idaho supervolcano sequence and our stratigraphy that we've been working on. Are we good? Do we have any problems, concerns? Quick, we good? All right. All right, let's do hand gestures quick. What does this mean? Cascade, no. What color? Red. It's nothing but this today. I doubt we're going to see any blue today. Blue is Cascades, yes. Hornblends, pumices with hornblends. Dacite, that's a new word to us right now. Some of you remember what a dacite is, a special kind of lava. Dacite is a new blue thumbs up, Cascades, yes. But the Cougar Point Tuff is red, Idaho red. The Cougar Point Tuff, which is the star of today and the star of much of what we've done lately, is Cascades no. And Barbara Nash is telling us exactly why that is. You've got the Barbara Nash paper. I might come to you a little bit, but I want to emphasize what we stumbled into late. The room's settling down, so I'm doing the bold open right now. Thank you. We stumbled into it. It wasn't an act. We all stumbled into it together late on Tuesday. Nick? And we have a theme that I think I might work on for quite some time. Lower Ellensburg Formation, not barely Ellensburg, but lower Ellensburg Formation, is going to be a lot of red. And the red is specifically Idaho. And the Idaho scene, the Idaho source, comes alive 15.2 million years ago. Starting 15.2 million years ago, we stumbled into this together. And I'm coming to you in just a bit. 15.2 million years ago, something happens in Idaho. Idaho comes alive, and suddenly we start receiving all sorts of literal Idaho through the air. And it's falling onto the ground, and we're going to go bang on it this afternoon. James has gallon bags for everybody. Isn't that what you said? You've got enough bags for everybody?
Sure.
James has some sampling bags. Others will be bringing some accretionary lapilli. We'll be finding these other cute little discs of silica, the ash itself, some quartzite cobbles. So there's a lot for us to set up today. And if you're not coming with us, whatever. It's a free country, but you're going to miss out. But what's the theme? 15.2, everything comes alive, everything starts showing red. So in our stratigraphic column, remember the lower Ellensburg, as I'm defining it now until I decide to change my mind, is the top of the Priest Rapids to the top of the Elephant Mountain. That's going to be our Ellensburg Formation lower, the lower Ellensburg Formation. Barely Ellensburg is below that, but between Priest Rapids and Elephant Mountain is our time window for the next few lectures and our field trip today. Specifically, the Sela member, the Sela sediments, which are just underneath the Pomona basalt flow, are the star of the show today. We highlighted last time quickly, but I want to do more right now, that the Cougar Point Tuff number 7, which has been carefully dated at 11.81 million years ago, is right at the very top of this batch of Sela sediments. Sela sediments sit on top of Umatilla basalt. It's a dud. I don't know anything interesting about the Umatilla. So it's going to be on our sketches. It's a dud. Okay? I got nothing to say. And the Mabton sediments, I don't care. Okay? So we're above the Priest. We're into the lower Ellensburg. Mabton, I don't care. Umatilla, I don't care, until somebody said, maybe Sky will say, well, you really should pay attention to the Umatilla. There's a really interesting story. I haven't heard it yet, so we're ignoring it until proven otherwise. But the Sela is mostly red, I think. And whether that's Idaho or Idaho combined with quartzite cobbles, which is Columbia River coming from the north, not Cascades, I do care about that, and I care deeply about the Pomona basalt. So the Pomona and this Cougar Point Tuff number 7, those are kind of a package deal. Apparently we can follow and find the Pomona in many places in central Washington, and right beneath that Pomona is this Cougar Point Tuff number 7. Where'd it come from? Idaho. I'm freelancing already. I'm not even doing my bold. I just felt like I wanted to come to this first. So yeah, I'm flipping this around again, Gavin. Merry Christmas. There's another sediment package that we will not see today called the Rattlesnake Ridge member, but I mention it now because there's another Cougar Point Tuff, Cougar Point Tuff number 11, dated at 11.22 million years ago. Some of you aren't here mentally. I get it, okay? You're taxed or whatever. I can get you. I can reach you, but not yet. I'm just laying the groundwork from the local stratigraphy. So today we're basically in here when we go up to the quarry. And eventually we will be up here. And I know where I want to go. After the midterm, which is a week from today, after the midterm, we're going to be up here in the upper Ellensburg. And I know a few major stories that I want to lean into, but there's also stuff that we're going to discover together. So we are slowly working our way younger and younger. We okay? Comfortable? Now I am going to involve you, okay? And this is going to go fast. And I'm coming at pretty much a lot of people in the room. I want to do this more carefully, and I want to add a couple of details that I'm excited about. Let's involve people, though. What's going on with this board? I didn't erase it from last time. What happened 15.2 million years ago? What's on either side of this big fat line? How does this have anything to do with the quarry we're visiting? Gavin.
I don't know if you want to name it, but remember what it is. On the left side, we have the old exotic terrains.
Exotic terrains.
We have the old crater.
Correct. So let me stop you, Gavin. So this line, which I just drew hastily, but I think it's pretty accurate, is a very important geologic boundary. I want to use slightly different verbiage than I used last time. To the east of this line is Precambrian basement. We know Precambrian is the oldest geologic era we have. We know that if you have a foundation of a house, that's the first thing you pour. The foundation is the oldest, lowest anchor to that house. So we have a substantial Precambrian basement, otherwise known as a craton, and it's thick, and it's hard, and it's old, and it's together. It's got its shit together. It's a good foundation. And it stretches from Boise, Idaho, clear over to the Appalachians. But there is part of North America, including us, that doesn't have a craton. It doesn't have a Precambrian basement. Are you aware of this? I think maybe half the people in the... You're all geology majors, but maybe this hasn't been emphasized too much. I mean, there is basement rock west of this line, but it's not a continuous, solid, stubborn, thick Precambrian craton. Instead, it's a bunch of rocks that were added to North America over the last 200 million years, exotic terrains. Can you give me some examples of names of exotic terrains, by the way? Does anybody have that in their head? I've done a whole number of programs on these over the years. Indigo. Quinellia, wow, yes, right. Quinellia is one of the exotic terrains exposed in northern Washington. Gavin.
The most recent one is Silesia.
Silesia, which we're about to talk about, is the most recent exotic terrain. Anybody know any other names? I'm just curious if this is on your radar screen.
Mount Stewart.
Mount Stewart itself is an exotic terrain.
I don't know the name, but the sandstones up in the San Juan Islands.
There is some sandstone up in the San Juan Islands, and it's part of the Nanaimo group. It's exotic terrain, thank you. There's a dinosaur bone in that stuff. Okay, I don't know if I'm speaking a foreign language to you, Sage, but there's all sorts of stories involving this, but it is not this solid Precambrian basement. I feel like I need to draw something. I'm still not getting some of you. So let's try this. I'm in this right now if you want to follow along. Yellowstone hotspot slips beneath something 42 million years ago and something 15.2. We know what the 15.2 is. Can you put it into words? If I'm using this phrase, the Yellowstone hotspot is slipping beneath something. Courtney, what's it slipping beneath 15.2 million years ago?
15.2 is when you can tell that the plume is crossing over into like the old Precambrian.
It's slipping beneath, the Yellowstone mantle plume is slipping beneath the Precambrian basement. It's slipping beneath the craton. That's what I feel like I want to draw. So this is going to be super cartoon time. This is, let's say, Boise, Idaho. This is a cross section. Can you see this, Austin, from where you're sitting? This is a thick, so let's make a craton here. A continental craton. It took hundreds and hundreds of millions of years to put that craton together. That's a whole nother story. I don't know anything about Precambrian geology because we don't live with a Precambrian basement here, and I've done most of my teaching here. I left Wisconsin. So this Precambrian craton is the basement we're talking about. And beneath this continental crust is the mantle of our planet. So our big line that's on this map here that goes through Boise is this big line right here. And what we're emphasizing today, and this is the thing we fell into late last time, is that the Yellowstone hotspot, which is coming from deep within the mantle, there's still all sorts of disagreement about why the mantle plumes are where they are, how they form. I think the most conventional message now is that the Yellowstone hotspot, as well as other major as well as other hotspots like the Hawaiian hotspot, are truly coming from the base of the mantle, the core mantle boundary. But why? That's a whole other thing. You want to talk about mantle plumes?
No, I was just gonna, it made me think about it. Do you think it could be kind of like solar flares? So it happens with changes or something like that?
Nick is wondering, can we speculate on why the mantle plumes exist? Is it tied to something like solar flares or some sort of magnetism? Anything is open. The geophysicists I know don't have it nailed down. So I don't think we'll spend a lot of time on that. But we know these mantle plumes exist, and for our purposes, they're stationary. And so far, what I'm saying is that our old North America with a solid Precambrian craton is drifting. It's drifting west. And 15.2 million years ago, it is truly drifting over this stationary mantle plume. We all know this, right? The mantle plume looks like it's coming towards Wyoming, but it's us that's drifting over the top. Okay, good. We got head nods there. So the 15.2 is what we're doing here. And just verbally, do you see the connection to what we were doing last time? We're not going to get these incredible, highly silicic, vitric tuffs where we are truly kabooming Idaho, one after another, until we can get this thing under the craton. Because the craton is under southern Idaho. We're going to involve this entire Precambrian craton as well as the platform and the other sedimentary rocks on top of it. So that gets us to our geochemistry, which I've got a little bit more. Barbara Nash watched the episode, by the way. She was in class with us last time. She heard you asking me about the exceptions, about the hornblende and the two, it's cool, man. She's maybe watching right now. Barbara, if you're there, hi. So that chemistry that Barbara Nash has in her papers is clearly showing this transition 15.2 million years ago. I got to do this quickly, though. But there's another slippage. That same Yellowstone hotspot, I didn't get this idea until talking to Gary Paul yesterday, who's a photographer / geologist who's been watching these and is really interesting to talk to. We were up filming in Leavenworth the last couple of days, and he says, yeah, I saw that program. You're not talking about Yellowstone mantle plume slipping beneath North America? I'm like, no. Maybe I should do that tomorrow. So that's what we're doing. So where is our craton edge? It's here. Where is North America's edge? It's here. Are you aware that Silesia, this thing that everyone agrees was a large igneous province off the coast of Northern California and Southern Oregon, starting 56 million years ago? I'm going to do this quick because we're off topic. But this is conventional wisdom now, that the same Yellowstone mantle plume that's here today and the same Yellowstone mantle plume that's kabooming through southern Idaho, if we go far enough back in the history of the Yellowstone mantle plume, it's out here. It's not under a craton here, it's not under any continental crust. And so that same mantle plume is going to build a basaltic island. And it's not just an island, it's a massive oceanic plateau made out of basalt. So that concept is odd, that the same thing that's making a basaltic, it's a serious German chocolate cake, way bigger than ours. That same mantle plume is going to start making different kind of lavas when it gets underneath Oregon, and different lavas yet when it finally gets underneath the Precambrian craton. So 42 million years ago is when North America, when Oregon, when the exotic terrain stuff starts crossing the Yellowstone hotspot. And then we keep dragging North America, and that same Yellowstone hotspot slips underneath Idaho, 15.2. I'll say it one more time, see if there's any reaction, and then I do want to move on. This Yellowstone mantle plume, which was centered underneath Silesia, which is now the bedrock of Western Oregon and Western Washington. Originally, the Yellowstone mantle plume built Silesia. North America started coming closer and closer to the heat source, and the Yellowstone mantle plume slipped underneath Oregon for the first time 42 million years ago. Keep dragging Oregon over the mantle plume, therefore it looks like it's going to get closer and closer to Idaho, and it does, because the stationary heat source is being overridden. The same mantle plume slips underneath the Precambrian craton 15.2. Now it sounds like I'm just saying the same thing 42 times. 42. Is there any reaction to this? Are you confused by this? Are you excited by this? Or should we get off of it? Where's the subduction zone at this point? Good question. The Cascadia subduction zone begins 46 million years ago, seen, and so we have some geometry problems where we have not just a drifting plate, but we have a subducting ocean plate that's going underneath North America to the east. I definitely don't want to go in this direction much further, but we lose the clear path of the Yellowstone mantle plume between 42 and 15 because that mantle plume is dealing, like, can I do it? I feel myself going too far in this direction, but it's fun. Seems like, okay, I guess if you want to do this, that's fine. And if you even want to bring Oregon over the mantle plume as well with a bunch of fruitcake exotic terrain stuff, that's fine. But seen is like, don't we have this as well? And we do. We've got a subducting Farallon plate through the whole story. So Gavin or whoever was asking me, James, is the hot spot burning holes through the subducting plate? And there's evidence for that, but there's differences of agreement on how a hot spot interacts with the subducting plate as well as a changing constituent within the continent. I've created a monster now. I can't shut you down now. Nick?
Chris has a video that he showed us in mineralogy with basically exactly what you said with the subduction zone and Silesia and like that whole mess that happened.
It's a mess. And I'm putting the brakes on this because our payoff is, it's almost like the way I view it is the Yellowstone mantle plume now is clearly offshore making Silesia, older than 42, and it is clearly under Idaho, younger than 15, making our Vitric Tuffs. And I think I don't give a shit what's going on in between, personally. And yet I'll answer more questions. Chris? I don't give a shit, Chris. Why? Chris, why? Just kidding. Yeah, Jeff Tepper. Name dropping now with Chris Mattinson and Jeff Tepper. Good.
When you were talking about how like subduction shut off for a while, and it started back up.
Yeah.
Isn't it around about this time?
It's in there. Yeah. Basically, Jeff Tepper has a beautiful tectonic model that pretty much ignores the Yellowstone mantle plume. And it's mainly to the south of his story. So he's saved by some geography. And so I think we'll just leave it there. Thank you for your entry. I can feel you now. I can feel you. Okay, 22 after. I want to talk about the Bruno Jarbidge caldera. And I did it super quickly and didn't even use the name before. It's on your outline if you wrote down the outline. Do you need it again? So let's do some basics first. Hang on. The Cougar Point Tuff, which we're all going to see this afternoon, 30 feet of it. 30 feet. And yet most of it is reworked by water. It's just the very base that is truly pure ash that fell out of the sky. That's new for me from Barbara, I think. But that's one thing we'll look at. We'll get at the base of the Cougar Point Tuff, number 7, in the quarry. We'll look at the very base and see the accretionary lapilli. Those are the hailstones we were talking about last time with the screwdriver. That apparently is pristine and undisturbed. And at some point, maybe it's obvious once we have this on the brain, that we'll see water. We'll see rivers, streams moving this stuff around. And so the upper, I don't know. If there's 30 feet of tuff, maybe 25 of it is reworked, meaning it's sloughing off of nearby hills 11.81 million years ago and piling up at the spot we're going. And I'm confident of this because if you follow that Cougar Point Tuff, I'm going to say CPT from now on, okay? It's quicker. The CPT 7, that's the one we're going to see. I'm confident that's the local area, it's 30 feet, but if you follow CPT 7, one county that way and one county that way, it's less than 10 inches. So it's not 30 feet of Tuff everywhere, otherwise this would have been figured out a long time ago. The Cougar Point Tuff 7 is coming from, all we know so far is the Yellowstone hotspot tract. It's not coming from Yellowstone itself. It's because the Yellowstone mantle plume 11.81 million years ago was not in Wyoming, right? So you've read the paper. You know that there's a town called Twin Falls, Idaho, in southern Idaho. It's the only nearest town that makes sense to at least some people who know that drive. Twin, as the locals call it. You going over to Twin? Yeah, my uncle lives in Twin. All right. So to the south, doesn't matter. Near Twin Falls is a circular caldera, similar in scale to the famous Yellowstone caldera, who your precious Hannah Shamloo did her PhD on. Hannah, we get it. Okay, she worked on one of the airfall tuffs from recent Yellowstone supervolcano activity. But the same mantle plume we've been talking about today was here by Twin Falls 11 million years ago. You know the exact date. And there's ash flow. Ash flow. We know the difference, don't we? If we have a supervolcanic eruption, it's not a cone. We don't have to do 101 stuff, do we? So we have a caldera forming explosion. There's a ton of ash in the air. Much of it is this ground-hugging cloud of ash and debris that's flowing over the landscape in all directions. I don't think this is new to anybody. And that ash flow tuff, or an ignimbrite, that's another word for it. These ignimbrites come to rest, and they're so hot that they weld. And the very base of that ignimbrite, or that single ash flow tuff, has a very glassy base. And as you work your way to the top of this ash flow tuff, or ignimbrite deposit, it's super frothy at the top. That's physically evidence of what happened at ground zero during one of these kabooms, because the Yellowstone mantle plume is underneath Twin Falls, Idaho, with Precambrian basement involved. So what are we talking about? We're talking about going to a quarry up here. It's not ash fall, it's not ash flow, it's ash fall. But it's the same chemistry. So I have a really sexy diagram that I guess I need to get to you sometime, but I don't have it ready for you yet. I have it printed out for myself. Maybe I can just show it to you. In southern Idaho, there are these canyons. So if you're a whitewater raft person or something, you know about the Bruno River Canyon or the Bruno River Gorge or the Jarbidge Gorge. I've never been down there. It's no man's land. It's like almost Nevada, California kind of stuff. It's remote, close to the Oahe. Nick, was that funny?
No,
was that dirty somehow?
No, you just
remote is that what the kids are calling sex now? Remote?
No, you just said it's
You're
the
gonna go
middle of nowhere, California, and I just thought, yeah.
You never know what's going to turn this guy on. In these canyons of southern Idaho, it looks like basalt stratigraphy, but it's not. What are these layers? They are ash flow tuff layers, not ash fall. This is inside of the caldera, the Bruno Jarbidge caldera, and there's a sequence. It's like a Grand Canyon, but these are essentially welded rhyolites. So each kaboom has a specific hard bedrock record where you can bang on the rock, break it open, sample it, send it to Barbara's lab, and get ages. And I'm not going to have you memorize all these, but there's like 10 of these. There's 10 Cougar Point Tuffs. There's 10, let's count together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 separate kabooms just with this one caldera. There's 10 ash flow tuffs, ignimbrites, and there's 10 separate ash falls, fallout tuffs, that up until Barbara's work were only found over here. Where am I over here? I'm like New York, or like, I'm specifically like Louisiana, I'm Nebraska, I'm Kansas. There's a bunch of like animals 11 million years ago that are getting choked out with ash, and there's this incredible rhino fossil bed in Nebraska from one of these kabooms in Idaho. It's freaky, man. It's amazing. That's one of the Cougar Point Tuff, the CPT ash falls in Nebraska. But Barbara's the first to say, she didn't say it this way, but I'll say it this way for her. Barbara, I'm going to say it for you. Barbara's like, these are super eruptions. I want to start looking up here. There should be ashes from these kabooms up here in Washington. Plus, my daughter lives in Bellingham, which is true. That's why she started sampling up here in Washington on her way to visit her daughter. So a bunch of our ashes at Mattawa, Sentinel Gap, which everybody thought were Cascade. Everybody thought they were blue. They're fucking red. And she expanded the reach, which makes sense if you think about it, of these supervolcanic eruptions. So Bill Bonnickson from the Idaho Geological Survey long ago came up with this Roman numeral thing. So again, I'm not going to have you memorize it, but like the first one is CPT Roman numeral 3, then 5, then 7, then 9, then odd for some reason. So we're going to number 7, and I think there's a decent chance later on in this class we'll go to CPT. Which one is it? You got it. Yeah, on the yellow thing you've been clinging to much of the dates we keep futzing with because I made this long ago, but I do have those 2 CPTs in there. Thank you. So you can see the CPT 11 is right underneath our beautiful Elephant Mountain. Okay, I'm jazzed today, obviously, because I want you to get the most out of this. I don't want you to go, it's hot. I got my monster drink number 4. Where am I? I think I'm cramping. Are the vans leaving yet? What's ash? Tink, tink, tink. James, you got a little Tupperware? And then I'm going? No! This is ash that's incredibly thick with these cute little details from there. And that's before her paper in 2012. Nobody had any idea. That's exciting. How many more ashes, you saw the interview, how many more ashes are going to be proven by her or somebody who's doing her kind of work up here in the Okanagan or up in BC or whatever? It'd be super fun. She's got the instrumentation, she's got the database, and that lab's reopened after COVID, but she's retired. Gavin, questions about Barbara's retirement?
Mostly about the super eruption.
Oh, about the super eruptions.
Because we have the evidence now that the ashes, 30 feet of ash that we are finding here, have we changed our models of what the current super, like where it is right now, what it could do with a super eruption?
Are you asking about hazards in the future with the Yellowstone mantle plume?
A little bit.
And are these new discoveries helping us realize the significance of what may be coming? Probably not. But yeah, I think if we keep cataloging the regional extent of these ash beds from long ago, I just have to say something. Gavin, I really like you. You're really doing a nice job in class. I noticed this up in the quarry last time. I have like 3 seconds to give an answer before you start looking around at something else. What is going on? Y'all play video games or something? Like that? 3 seconds is my limit before you just start literally tuning out and starting to look somewhere else. I love you, Gavin. Jesus. So I need a stopwatch. I need to literally bring a stopwatch in. And if I get a question, 3 seconds, I'm going to cut myself off in the middle of the 4th word. So That'll be my little present to you. So yeah, Gavin, I think the future, with each additional super eruption ash bed, the scale of this story becomes more and more pronounced. And most of the attention has been on the last 2 or 3 eruptions here, a la Hannah. Any more on this? I didn't mean to, I hope you got the tone of that right. I meant it mostly to be funny. Chris?
So primarily, like what we're looking at for ash layers, are they just from the Twin Falls caldera?
No. Well, okay, interesting question. So there's some mystery here. Apparently this time window, so that I have 10 major ashes from the Bruno Jarbidge. And I have it written someplace, I probably can't find it. Chris, I'm just going to slam myself now. I have all these papers ready to go. Here. So our 10 major kabooms, Chris, for just this guy, run from 12 to 10. And Chris is essentially saying, okay, so you got 10 big kabooms for that one. Do we have 10 more from the one that's over here and another 10 that's the one for over here? Remember that Kilgore one that was important to me? That's the Heisey volcanic field, and there was 3 of those that I was mapping, and that was the one at Baker City that was found recently by Barbara. I could go on there, but Chris, it's kind of a mystery why the mantle plume was doing so much action during this time window. And it appears to be less frequent. It is less frequent. The kabooms are less frequent as we get closer and closer to modern day. And the basement isn't any different.
So does our regional track where all our fallout start getting smaller and smaller and smaller? I mean, I guess what I'm getting at too is like what track of time are we really looking at involving our specific ash layers?
Barbara's really the first to have done this, so we don't have the body of data that I think you're wanting. She's just been hop, skipping, and jumping around to get ashes and tying them mostly to these centers. But it's hard to, we don't have enough data to have the trends that maybe we're heading towards. James?
I was hoping to provide some insight to that question that Chris had about like why is there all these big kabooms in this time period.
Great, James. Why?
So I watched this video yesterday. I think it was based off the Yellowstone Caldera Chronicles, and they thought that high basaltic like eruptions is usually associated with more rhyolitic eruptions because that basalt is heating up that rhyolite to actually erupt. And
Okay.
since the CRBs are still going on,
Okay.
maybe it's moving that rhyolitic magma.
That's addressing why this was a especially active time here?
Not that specific area, but that's like my thought.
Well, let's go in that direction, James. Yes, thank you. So back to what excited me in class last time, and I want to tap back into that again. Don't let me quit before we get to quartzite cobbles, okay? Let me do that now. So some of you are excellent students and you're about ready to graduate, so you know a lot about geology. Some of you are just beginning in geology, like sophomore level, and some of these basics of geology are not quite there in your head. So I'm not going to name names, but we talked about the quartzite cobbles being a Cascade no. And a few of you emailed me and said, confused about that. My dad and I go up in the Cascades all the time and we find all sorts of quartz. So why is quartzite cobbles a no when we're finding all sorts of crazy amounts of quartz in the Cascades? And the answer is, there is a difference between quartz and quartzite. So we don't have a lot of quartzite in our state. I took this sledge, which I never use because I'm secure in my manhood, but I went out here and didn't look like a man. I was like chasing this thing around, this cobble, in the middle of folks who are out watching their movies as they're walking across campus. It took everything I had to get this thing open. These quartzite cobbles are incredibly difficult to break open. I wouldn't waste your time today except to say there are thousands of quartzite cobbles in the quarry. Indigo, it's more than ash up there. And they're blue. No, they're not. Shit. And they're red, right? Red means Cascades, no. So there is quartz. I screwed up. There is quartz in the Cascades, true. Veins of quartz, yes, a very common rock-forming mineral, quartz. Quartz veins, quartz crystals, everything else. But quartzite, we know what that is, right? This is quartz sand that gets buried, pressurized. We crush each quartz sand grain. We make a quartzite. It's a metamorphic rock. We have a whole mountain of metamorphic rock up in northeastern Washington, and then the Columbia River picks up some of that quartzite, bedrock, metamorphic, and brings it to our quarry. That's a source that's not Cascades. Red quartzite cobbles. And as I don't know, I might back off of this. Sky doesn't want to talk today. I feel like I want to go to him right now, but he says, I don't want to talk. That's fine. I'm starting to wonder, and I've read Hans Schminke's PhD again, all 100 and whatever, 400 pages of it. I think the dominant rock type in the Sela is these quartzite cobbles. I mean, it's dominantly red. I'm super confident of that. I'm wondering if I'm going to see any blue. Are we going to see any blue in the quarry today? Any Cascade, yes, in the quarry today. I wonder. But another question is it all quartzite, which is from the north, and then some Idaho vitric tuff that gets baked by the Pomona? Idaho baked potato. Baked vitric tuff. So I'm trying to give us some narratives to have in our mind as we are collecting and looking at the quarry. That's ultimately what I'm trying to do here today. And I have many of you engaged with some of these concepts. Okay, you have a couple of handouts that you got from last time. If you have them handy, I want to add to those a little bit. Again, we're setting up the trip. The accretionary lapilli you have, we don't need to talk more about it. This one is a drone shot nearby with our Idaho asphalt tuff. That's the Cougar .7. And you'll notice a surprise. Based on how I'm presenting Cougar Tuff 7, what's the surprise from this labeled photo? Ryan? Yeah, man. Okay, what's up? So Elephant Mountain has Cougar Point 11 directly underneath it. And Pomona has Cougar Point 7 directly underneath it. And so it seems like there's a mistake here somewhere. And I was all prepared to say, you know, I was wrong. I was so dumb 7 years ago when I made this field trip handout. But I'm not going to say that. I'm happy to say that, by the way. But again, I reread Hans's PhD pretty carefully under the oak tree last night. And it is the Elephant Mountain, the same Elephant Mountain where I dropped my hammer down the crack, those same Tootsie Roll columns and Drumheller channels. That's the same flow that's right up here at the very top. And yet our Cougar Point 7, not our Cougar Point 11, is directly underneath in this photo. I think the answer, did anybody watch the long video? I tried to send you short videos, but I actually sent you one that was more than a half an hour long, I think. And I was walking with the siblings. Some of you watched it. Do you remember the part where I got confused? Which happens in every video, but I was about halfway through, I was walking with the siblings, and I finally got to that Cougar Point Tuff 7. What do you remember me being obsessed with, Raquel?
Was it the vesicles and the something red?
So I was in the brick red, so you can see it in this photo, perfectly done there. So at the very top, and we'll see this when we meet at Lennis Lake, we'll see this brick red zone up there high. And I'm like, there's the top of the CPT-7. And I don't know how many times I would be on field trips and I'd say, that's the top of this Idaho. Everybody, that's ash from Idaho? What was the wind doing? Okay, we're past that. But when I got up there with the siblings, Raquel, I'm like, I expected this just to be Pomona lava baking the top of the Idaho ash and welding it into glass. And yes, when that's private land up there, we're not going there. But when we got up there, I was surprised that the brick red stuff was basalt and it was full of vesicles. I now realize, like 90% sure, that that's the Pomona. The Pomona is ending out right there. So everywhere else that the CPT-7 is exposed by Ryan's House and Sela, there's Pomona that I guess is baking the top of the CPT-7. But at our quarry today, or at least right around the corner where I was with the siblings, the Pomona's there, but it's like, I think, rafting, remember? Invading our Idaho Tuff and petering out right there. That's what the vesicles are about. And then, confusingly, the Elephant Mountain's like hanging out right out there too. So I don't think there's any Rattlesnake Ridge. We're into some detail now, but I'm confident it's Elephant Mountain that we're going to see up above the quarry. And I know it's CPT-7, but we're missing some section, I guess, is what I'm about to say when we get there, sweating our asses off. Raquel.
So that rafting, is that the reason why the red layer kind of disappeared as you walked further down the cliff?
Nothing's easy when we get out there. So yes, I was trying to follow it laterally in the video. Thank you for sticking that far. And I started losing it. And is it because it was rafted? Or again, is it because the Pomona, which covers a fair amount of central Washington, is truly pinching out to nothing? And so I couldn't keep following it because the lava was truly ending. I don't know. I can't remember if we're going to see some of the brick red today at the quarry. Maybe we're not. Maybe the entire quarry is going to be in here. By the way, why were they quarrying? I'll get to you, Chris. Why were they quarrying that ash? That was a commercial quarry back in the 1960s especially. Say again?
Was it for cement?
Yeah. What were they using the cement for? To pour the dam. So the Wanapum Dam and the Priest Rapids Dam, two major dams on the Columbia, were made of cement, and the cement was fortified with the Idaho ash. And even J. Hoover Mackin, the first paper that I guess I was responsible for in 1961, when I finally read that paper, I'm like, that's why Mackin was here in the 1950s to work out these lavas. He was hired by the people building the dam to figure out what the layers are and figure out where best to build the dam and everything else. So there was a big boost in knowledge of our basalts and our sedimentary interbeds in the 1960s because of these plans to build the dam, Wanapum and Priest Rapids. So that's why the quarry is there. The quarry hasn't been used since the 1960s. And we'll see another quarry across the way, same thing. And for years I heard people talking about the Pozzolan mine, which is where we're going. I'm like, Pozzolan? Is that like the family? It's like Jerry and Bernice Pozzolan? And no, Pozzolan is an actual word for ash being added to concrete, to cement. I think the Romans were even doing it. So I don't know the physics of it, but that's the context of this whole thing. I got 2 minutes. Anybody else? Chris, you guys still got some? Chris is on fire today.
Well, I was just looking at our strat column and
Yeah.
our handout. Is that what's happening with the human seal? Has it been pinched out and that's why it's not, we're not seeing it at all? We're just seeing Priest Rapids and ash and then Elephant Mountain.
Thanks, Chris. So Chris is asking about the Umatilla pinching out. Why aren't we going to see Umatilla where we're going today, for instance? I think the thing to get in mind, there's two messages about why we don't see every layer in every place. One is the lavas have different volumes. So if you're making a cake and you've got chocolate frosting and you don't have much chocolate frosting, you're going to cover like 2/3 of the cake, but you can't spread it all the way out to the edge of the cake. You don't have enough frosting. So I think that's a factor. Like the Umatil is a dud in part because there just wasn't that much material compared to the Grand Ronds, of course. But I think a sneaking narrative might be if we raft a bunch of stuff and we do a bunch of digging and we do that whole Rosa going into the Muma business, then we're not covering as much ground because we're tunneling in, we're doing all sorts of bulldozing, and suddenly we're not covering as much ground because of that. I still get bummed out when there's rafted sediments because it screws up our order. And then I just get confused. And then I just like sulk and drink a Monster and go back down to my car and leave. I love Monster. This episode brought to you by Monster. Monsters have never crossed these lips, I'm happy to say. But maybe I should try. All right. Different kind of a meeting today, in part because I wanted to give you as much context as possible so we could really enjoy that quarry. And am I going to be lecturing to you at the quarry? Absolutely not. You're just enjoying it while we're up there. Okay? Thank you. I love you. Sabrina, take it away. 1:15, you guys leave. Sky and I will be driving over there. We'll meet you at Lennis Lake. 2:15, meeting time. Thank you. You're leaving at 1:15.
I wanted to show you something. The lesson after we did the diatomaceous earth stuff,
Yeah.
the day after that, I was working on the farm using diatomaceous earth.
Crazy.
Yeah.
So they could,
Yeah,
they're
so-
buying it, but they could easily just go over and
I know, that's
haul a
what I'm
bunch in.
saying. Like, why don't we just drive over?
All right, everybody, let's maybe another camera. Yeah.
Because we're saying stuff's being a little bit pinched out in Saddlemouth. And I was curious like why that area was higher than the other areas, so I looked into it and it's all been uplift.
We're ignoring that 100%, but I will have to talk a little bit at our meeting place
I was
because
just
we've got a
wondering if it's-
huge fall.
If it's been uplifted but it's been squeezing out, are we seeing like the end of some of these lava flows then? Where it's
Yes.
been, okay.
Not always,
Not
but yes, the thing I'm ignoring through the whole class is that these ridges are starting to grow, so you can't just have these lavas
Right.
cross the cake if there's big roadblocks in the way.
Because Lisa dropped some knowledge this morning that made it kind of click for when, on our first stop, when we were looking across the river, all the leaning, and then you'd see like a tower, and she goes, oh, it's because a lot of that area has like a monocline. Never really, I guess, thought about them still going in the same direction. They've just been swept away. So I'm just trying to like picture everything where
It takes a while.
regional.
It takes a while, it's a nice combo between geomorph and this that
Yeah.
you'll get two different perspective each time. Good, Chris. Good. Okay, a couple quick Q&As with everybody. If you want to do an uppercase, did anything interest you today that you'd like to ask a few questions? And otherwise, I need to hit the road. How long did the Grand Ronde take to cool? Did it affect newer layers? Good question. I don't know. I'm guessing that even the thickest Grand Ronde lavas go from liquid to solid in a year? Less? More? I don't really know. I don't know if the scale of these basalt lavas are so huge that it's difficult, I think, to quantify cooling rates. John, would the presence of the hotspot cause uplift that would change the drainages and source of the sediments? I think you know the answer to that, John. Yes. And we are going to get there with got some weird, I don't know what's going on with the broadcast. Hopefully it looks okay to you. We're heading there. There's going to be some detrital zircons from the snake that are going to show up exactly where we're going today, and we need totally different drainages then. Kirk, is the strontium 706 line the edge of the craton and the whiz? More or less, yes. Thank you. What are you hoping to get the students to see, learn at the core? I mostly just want them to have fun enjoying. They don't need to hear me lecturing. I just want them to see the scale of quartzite cobbles, have them sample some of those delicate accretionary lapillis, and there'll be some other relationships that will be confusing to them. And they will come over and ask me like they're in second grade with all sorts of hope in their eyes, and I'm going to say, I don't know, what do you think? And they'll be disappointed by my answer. But I'm not playing games. We still need to train these young people to think critically and be open to different ideas. And it's sometimes disappointing to me that they still just literally, I don't mean to be demeaning, they're literally running up to me and saying, what's this? And they have enough geology now, they can answer their questions. We should have a discussion, not just a little dog and pony show. There's two videos that are online that they have watched for this class session. One is called Saddle Mountains Ash, I think, or Saddle Mountains Yellowstone Ash. And another one is a Nick on the Rocks episode called Saddle Mountains Ash, probably. If you type in Nick Zentner, in Google, $100 a month, if you type in Nick Zentner Saddle Mountains Ash, I think you'll get the two videos we're talking about today. A few more. Patrick, how much overlap in activity at each eruptive center? Well, in the case of Bruno, 10 major eruptions, and it's pretty much all the same caldera, I think. Many of those volcanic centers are totally buried, so it's difficult to come through on anything. I don't know of any geochem on quartzite. The vesicles found where layers peter out. Yeah, I think so. Somebody's got something to say about the Umatilla. Okay, well, I'll track it down. Until I read that, it'll be a dud. Okay, everybody. Thank you for watching today. I love you. I'll give you one more shot out the window, and we'll see you on Tuesday for our next class session. Geology 351, over and out.
If that's interesting, you should watch that video. Yeah.
Thank you for all the nice comments. I'm just looking at the live chat right now.
Well, it is also crazy because
It's really nice to see all this positivity. Thank you. It's easy to take it for granted on occasion, but people are stressed out here. So it's really, personally, it's nice to see these comments. Thank you.
Here it's different. It's like there's like 20 different things happening.
Yeah, and it's not.
Okay, that's enough. See you next time, everybody. Goodbye.